Hey guys, welcome back. Today's lesson is absolutely nothing new at all. I'm just going to do another sample problem, okay? So hope you're doing well. Here we go. First of all the stuff you have to know cold. These are all of your first derivative issues that you need to know cold. And hopefully you've printed this out or written it out. And here are your second derivative issues. Okay, so again, if the title of the graph is the original function, then you can trust your eyeballs. Everything looks the way it should, and this should be easy. So I'm going to fly through this real quick. So, critical points. My critical points on the original function would be here and here. Out of those critical points come your maxes and mins. Yes, this is a max. Yes, this is a min. Because if the title is the original function, things look the way they should. Okay, increasing and decreasing. Yeah, this is increasing and decreasing is this stuff. Everything looks the way it should. Concavity. Concave up would be about here. Concave down about here. Okay, slowing it down. Inflection points are where concavity changes. So my inflection point would be about here. That's an inflection point. Again, everything looks the way it should if this is the original function. So this is my approximate inflection point. Okay, so the only thing that you might mess up is number 5. Okay, don't confuse number 4 and number 5. Okay, number 4, f of x decreasing, is just downhill. That's this stuff here in the middle, okay? That's f of x decreasing. But f prime decreasing, that's not the same thing at all, okay? F prime decreasing. Decreasing is a first derivative word. So let's go back to number 4. Looking at this one. This word decreasing means derivative of this, and that's why it's first derivative negative, okay? But hold on a second, going backwards. Okay, now looking at number 5, this decreasing means derivative of this. So that's why it's second derivative negative, which means it's the same as concave down. So the answer to number 5 would be everywhere it's concave down, which is all of this. Okay? All right, now let's do the harder problems where you can't trust your eyeballs. So again, if this is the original function, then it's an easy question. Everything looks the way it should. You just have to remember for number 5 that that means the same as second derivative. Okay, next one. All right, now this is no longer where you can trust your eyeballs, and you have to make sure you write your justifications first. Okay, so let's start with critical points. Critical points means first derivative is 0 or undefined. You don't have to state undefined if there isn't anything in the picture that is undefined. All right, well, look at your justification is a derivative and the title is a derivative. If it's a match, then that translates to height. If it's one derivative away, that translates to slope. So since this is a first derivative and this is a first derivative, this translates to height is 0. Okay, so height of 0 would be these guys. Whoops, hold on. Height of 0 here, here, and here. Those are my critical points. They no longer look like maxes and mins because I don't have the original function. Okay, now I'm going to move on to number 3. Out of these critical points come my maxes and mins. Okay, if those critical points, if the first derivative changes signs around them, then it's maxes and mins. So we're going to look at all of those critical points and find our maximums and minimums now. Okay, so for maximum, first derivative is 0 and changes from positive to negative. Now, by the way, this is good symbols for you. You can write that for you to figure out what you need. But on the AP exam, make sure you write that out in words. Okay, so first derivative 0, that we already found. That's the critical points. But also changes from positive to negative Well, that's when height changes from positive to negative. So positive is above 0, negative is below 0. So which critical point does the height change from positive to negative? That would be just this one here. Okay? Now let me clean that up. So this critical point was a max. The other two, the height goes from negative to positive, below to above. So those two are your minimums. Now I want you to stop and study that for a minute. Does that max look like a max? Do those mins look like mins? No. If you have the derivative given, then you can't trust your eyeballs anyway. A max doesn't look like a max. So you have to trust your definition, okay? So let's move on. I've skipped number 2 for now. We'll come back to it. Let's go to number 4. All right, number 4. Where is f of x decreasing? That's where f prime is negative. You got to write your justification first. Now again, the definition is first derivative. The title is first derivative. If it's a match, then that means we are looking for height is negative. Height is negative. So that would be everything below the x-axis, all of this. Okay, so my answer would be negative infinity to about negative 3.5. That's an estimate. And about 0 to 2.8 or something like that. Okay, now again, does that look like f of x decreasing? Does it look like this graph is going downhill? No, but that's because this is not the original function. It's the derivative graph. All right, so now let's go to, let's do number 2 now. Let me erase all this stuff. Now I'm going to focus on number 2. If you want to, maybe you can try to find that on your own. Maybe hit pause and see if you can figure it out on your own. Okay, I'm going to start with my justification. An inflection point is when second derivative is 0 and must change signs. Okay, now on the AP exam, you don't have to say equals 0, but you do have to say second derivative changes signs, but the equals 0 part might help you find it. All right, so we have a second derivative justification on a first derivative graph. We are one derivative away. That translates to slope changes signs. Slope changes signs. So this is positive slope, negative slope, positive slope. So where did slope change signs? Here and here. Those are your inflection points. So again, does that look like an inflection point on that graph? No. That's because this is not the graph of the original function. This is the derivative graph. So everything is one thing away. All right, let's do number 5. Where is f prime decreasing? 2 different ways of thinking about that one. Decreasing is a first derivative word. So this is derivative of derivative. So that's second derivative negative. Okay, or concave down, but that's not that helpful for this graph. If we're looking for second derivative negative on a first derivative graph, we are one derivative away, so we are looking at slope is negative. So that would be just this right here. Okay, so what is that? Negative 2 to about 1 point, negative 2 to about 1.2 or 3. Okay? All right, well, hopefully you guys are doing better. I got number 6. I skipped number 6. Let me get that one. Okay, last one, number 6. Concave up, justification would be second derivative is negative. Second derivative justification, first derivative graph, one derivative away, look at slope is negative. I'm sorry, I just totally said all of that wrong. I said I'm looking at concave down. I got to completely erase all of that. Okay, starting over. Sorry about that. I was justifying concave down. This is concave up. So starting over. F of x concave up is second derivative positive. Okay, Second derivative justification on a first derivative graph, one derivative away. So we're looking at slope is positive. So that would be slope positive here and slope positive is here. Okay, so my approximate answer would be negative infinity to about 2 and about 1.4, whatever you said it was before, to infinity. So to sum it up, always, if they give you the derivative graph instead of the original function, then always justify before you look for your answer. Not because they tell you to, you justify because it helps you find the answer. Then, if your justification is one derivative away, that translates to slope. If your justification is the same, then that translates to height. Okay? If your justification is a match, think height. If you're one derivative away, think slope. So I gave you one more quick worksheet on this today. Let me know if you have any questions. Hopefully it's getting better. I also gave you some AP questions today, and I wrote you a message about that. Super important. I'm very excited about it because I think you're going to be proud of yourselves when you realize just how much you actually know. Okay? All right. Here's the answers if you want them all summarized, if you need that. All right. Good luck, guys. Hope you're doing well. Bye.